In this clip we're going to look at loading a M2TS side-by-side video file into Viva 3D and converting it to 9-view autostereoscopic. Let's just take a quick look at one of the videos of this type of format. Here it is, M2TS. Add some filtering to improve the image quality. Reset that so it matches the resolution of the video stream. So you can see the typical format. On the left here we've got the left view, and on the right view the right view. This is taken by a stereo camera, and there's the usual disparity between the left and the right image, from which the Viva 3D software can actually determine depth. Here though we've just mapped it onto a cube within Viva 3D itself. You can see at the top of the cube, where you've got the oblique angle of the video, we have some artifacts. One of the things that Viva 3D does is a lot of processing on the GPU, so we can remove that by enabling MIP mapping. With MIP mapping enabled, we make multiple copies of the image at different sizes, so then depending on the angle we can improve the artifacts, improve the image quality, which is handled in the GPU, which is why this video, which is 1920 by 1080, is running, streaming at almost 500 frames a second on a low-cost AMD A10 machine. So that's the video we're going to convert. Now what we're going to do is the software will take the left and the right views and then calculate a depth map. From that depth map we then take the left image and then we will radially project it with a radial convergent projection towards the camera, which will bring the depth from the items within the left scene into 3D space, and then by moving the camera we can create 9 views. That's the basic technique behind the conversion that we're using. So let's open that form. Okay, so it's currently running in 2D plus depth mode. So there again we have the left image, and on the right the depth map that we're calculating. You can see also in the scene that we've added a number of other objects. So Viva 3D will convert the left-right side-by-side images directly to depth map and then to a radial convergent extrusion method that we use to recreate 9 views for autostereoscopic, but it also allows you to mix any type of 3D with it. As you see bottom left here we've got the time running, which is the current time now. On the right here we've got a mesh file there, which you can see I'm moving around, and I can also scale that. So this is what we call live 3D, and then it's not canned, so it can reflect any information, news, anything you need, including obviously the time and date. And here at the same time the Viva 3D software is stereo matching the left and right images and producing a depth map, which we can see here on the right. So then when we want to go to 2D graphics mode, we just click the button there, take that off, and let's just pause that one there, and by clicking 3DA we then get the typical autostereoscopic blur, which is where the subpixels are split amongst the views. If I control click 3DA, 3D autostereoscopic, we now get all 9 views. Now if I select 3D disparity, I can change the disparity to a higher level, and you'll see that the images more on the left are shifted in one direction to the images on the right. Let's speed that up a little bit so we get more of an effect. There you go. So if you look at the top left image here, you see the fountain is moving to the right as I move the slider to the right. But if you look at the bottom right image, as I move the slider to the right, it goes left. So we've got the 3D recreation of the left-right movie. You can see the left images move left while the right images move right, and vice versa. And that is what gives us the autostereoscopic disparity. Now you can see the fountain here on the top left image is almost touching the border, and on the right it's quite a way in. So we've successfully converted directly to 3D autostereoscopic. And that's basically it. You simply select whichever movie you want here in the editor here. Browse, select your left-right movie, and Viva 3D will do the rest. You can fine-tune the results to get the type of depth of throw that you want, or alternatively you can bring it into a 3D environment for normal use on 3D monitors, on 2D monitors, sorry. Just reset the position there. The radial convergent technique is very useful because it allows us to get rid of any noise in the projection and still maintain 3D quality. And that's it. So mixing of conversion of left-right, side-by-side images to 3D, to autostereoscopic, 2D plus depth, and 2D matching. And thanks for listening.